room, fan-shaped room. We have three line arrays, generic line arrays left, center, right. Three front fills and a back line. And over here we have the same thing, but I'm going to leave this alone. We're not going to optimize that, so we can go back and forth between basically pre-optimization and post-optimization. So here we'll just take a look at our front fills, and let's look at the low end. Okay, so here we have a lobe issue. This is, it's summing too much in this area, so we're going to try and get rid of that. If you look at the 125 hertz, we have the same problem. Okay, so to fix that, what we're going to do is put a little bit of delay. Call it 4 milliseconds. And now we just spread that energy out. So now instead of having two lobes here, we just have the one lobe. Okay, not to say that 4 milliseconds is the exact number that we should be using. To find that number, better to use a real, be in the actual room. But, so now we just have the one lobe instead of three lobes, which actually makes more sense because you have three loudspeakers, you have three lobes. So, it would be better if we could get it to look a little bit more like that. Beforehand, it looked like that. Okay, two big lobes, 114. So it's 3 dB up. Over here, that's pretty broad. The difference here, it's not that much. If we do 3 dB, so there's a 3 dB difference there as well. Okay. What next? Next, let's turn on our center line array. Look at that interaction. Again, we're only focusing on pretty much the low end. It's not that bad. Logic would say we need to take this guy and delay him back to here. We'll look at that. We'll see what it does. Positioning says one of these boxes is at minus 26. This guy's at minus 20, so that's a 6-foot difference. Delay, call it 6 milliseconds. Take a look. Okay. I'm not sure if there's... Okay. So here's our... This is with no delay. This is with delay. Delay, no delay, delay, no delay. Wait, did that backwards. No delay, delay. No delay, delay. Look at 125 hertz. No delay, delay. So it's spread out a little bit wider. Okay. So now that we've optimized this part, let's take these guys and go back to here. Well, first let's look and see what we actually got. Is it causing a problem? Maybe not. That's what I don't like about the color scale on this. Let's turn our front fills down, say 6 dB. Okay, much better. Just to make this comparable, we'll turn these guys down 6 dB as well. Okay, so here our problem is, oops, that guy, that guy, that guy, that guy. You know, that's a lobe, that's a lobe, that's a lobe. You know, here we might have a coverage problem. You know, this might be borderline coverage problem, but this is certainly a lobe problem. That's certainly a lobe problem. Look at 250 hertz. Oops. I keep canceling that prediction. 250 hertz. Not too bad, not great. But there's certainly some lobing going on there. 500 hertz. Not necessarily a lobe. Okay, so let's take collectively this entire group and delay them back to here. So these guys are at minus 14, and these guys are at minus 20. So 6 milliseconds. So we need to take this guy, all of these guys, at 6 milliseconds. Let's see, that's got 6, so what we're going to do is change that total of 12, and let's look at the results. Okay, and turn on this entire system, which has no delay on it whatsoever. I'll start at 125. Okay, 125, looking pretty good. Big time problems right here. Okay. Okay. This is with no delay. Okay. Even bigger problems. Okay. And then you got that guy. And then you've got basically one big lobe. These lobes have kind of minimized out a little bit. Divs have kind of gone away. That guy's almost gotten worse. So that might not be the exact right. You know, that was just a number that we physically drew out of our heads, but with a measurement in a real room, we could probably get that to be a lot better. Here again, this is with the delay. This is without the delay. So here we have our original two massive side lobes, and then here we don't. We've basically spread that energy out, so now we have a more dense filter, basically.